Time series data is everywhere, from financial markets and IoT sensors to application logs and performance metrics. But storing and analysing that kind of data in SQL can be tricky. Traditional relational tables can get slow, and queries over millions of timestamped rows aren't fun to optimise. That's where TimescaleDB comes in. TimescaleDB is an open-source time series database built on PostgreSQL, designed to handle large volumes of time-based data while keeping all the power of SQL. In this video, I'll show you what TimescaleDB is, how to get started with it on Tiger, and we'll build a small project together using financial data, ending with a live Grafana dashboard that visualizes our data. In full disclosure, this video is sponsored by Tiger Data, the creators of TimescaleDB. Tiger Data has recently announced a truly free tier on their platform where you can access all of this for free. If you want to try it out yourself, use the link in the description to create a free Tiger Data account and start building right now. So what exactly is TimescaleDB? TimescaleDB is a database built on PostgreSQL that adds special features for working with time series data. It's open source, developed by Tiger Data and fully compatible with standard SQL. You'll get everything you love about Postgres, such as tables, queries, indexes, and joins, plus the ability to handle massive, time-stamped datasets efficiently. Developers use it because it scales well, it's easy to deploy, and it feels familiar. You don't have to learn a brand new database language. You can just use Postgres, but it's smarter for time-based data. And in this video, we'll build a simple finance project together using TimescaleDB hosted on Tiger, which is Tiger Data's cloud platform. Let's start by getting our TimescaleDB instance set up. Go to tigerdata.com and click Try for free. You can use your email or a Google account. Enter your name, email, and a password you want to use, then click Sign Up. Once you're logged in, head to your dashboard and click New Service. You may see a screen where you have the first part of the free service selected. You'll see the type of service here, the storage and the region. Click on Create Service. If not, you can select the options you'd like. Select Real-Time Analytics from this page here to make the most of TimescaleDB features. Then select your preferred region and other details for your plan. Once you've selected everything, click on Create Service. After a minute or two, your instance will be ready. You'll see your connection string, which you can copy and use in your favorite SQL client, like dbeaver, pgadmin, or the Tiger SQL console. Now we're ready to load in some data. You may want to copy this config file or connection string to somewhere on your computer. Click Go to Service Overview once you're ready. For this demo, I'll use a sample crypto financial dataset, which is available on the Tiger documentation page. I've linked the page below in the description. The first step is to create two tables to store our data. The sample data we have has a list of prices each day and a list of assets. To create tables, open the service you have just created if you haven't opened it already. First, we'll create a table to hold the price data, which we'll call CryptoTix. In the SQL Editor tab, enter in the Create Table statement for this table. This accepts Postgres syntax and data types. Then at the end of the closing brackets, we add some specific criteria for TimescaleDB. We add this hypertable attribute, which is a type of table that allows TimescaleDB to work efficiently with the time series data. The partition column captures which column in the table is used for partitions, and the segment by indicates that the data is segmented by this column. We have the order by, which helps with the retrieval of data. Click the Run button and the table is created. Let's create the second table. We can delete the statement here and then type in the statement for our other table, which we'll call Crypto Assets. This will store the assets that are being traded. We click Run and the table is created. Now that our two tables are created, we can import some sample data. There is a sample data file for download on the project page, which we saw earlier. Scroll down to the Load Financial Data section and download this zip file. Now that the file is downloaded, there are a few ways we can import it. We can import the file with the browser here. We could use the PSQL command line to import it, or we could use our SQL editor. Each approach has its pros and cons. For this example, we'll import a file using PSQL, as I think that's a good way to demonstrate the connection as well as import the data. To connect using the PSQL tool, we will need our connection string to use and then add that using a terminal command. To use PSQL to connect to your database, you'll need to find your connection details. And to find these connection details, you can go to the Services page and view your service. On this page, you can see your connection information on the right. To use this in a PSQL command, you can use this value. We'll copy this and use it in the command line. So hover over this and click Copy. Now we'll open a terminal on Mac. If you're on Windows, you can open a command prompt. Then paste the command from the Tiger console. The command should look like this. Then press Enter. You'll be asked for your password. Type in the password for your database. If you've forgotten it or haven't set one yet, you can use the Forgot Password form on the Service page here by clicking More Details. After a moment, you should be connected to your database and your prompt should look like this. Now we'll import the data. We have our two CSV files inside the zip file we downloaded, so we'll import both of those after extracting the zip file. We can use the copy command in PSQL to import the CSV file. We specify \copy, then the name of the table to import into. In this case, we'll import the assets file first, so we specify crypto assets. Then from, then the name of the CSV file, then the keyword CSV header. It might take a bit of tinkering to get the file name and path correct. I've entered the full path to this file and on your computer the path will be different. Next we'll import the other CSV file. We write a similar command, but we use the other table called crypto_ticks and our other CSV file called tutorial sample tick. Run this command. This file is much larger, so it will take longer to import. Once it is done, we're ready to work with the data. This crypto_ticks table is a hypertable, and it is now optimized for time series performance. Behind the scenes, TimescaleDB manages partitions called chunks that make queries and inserts much faster. Now that the data has been imported, let's look at how we can query it. We can query it in either the PSQL tool in the terminal or our SQL editor, or an SQL editor built into the Tiger website. For the purpose of this demo, we'll use the SQL editor on the Tiger website. But if you prefer to use PSQL, you can just type your queries in the same terminal window after we imported the CSV data. First, we'll write a simple select query to get the first 10 rows, just to check that there is data in the table. We can click Run and we'll see 10 rows here. How many rows are in the table? We can run a simple select count to find out. We run this and see our result, which is about 5.6 million. Let's try something a bit more complex. Here is a query to get the average closing price per day for a particular asset. The time bucket function is a TimescaleDB function. It groups timestamps into fixed intervals like 1 hour or 1 day. We run this and see our results here. It's shown data in a couple of seconds, which is alright for a table with almost 6 million rows. We can also calculate a min and max using aggregate functions. We run this query and see the new columns here for the minimum and maximum prices per day. These kinds of calculations are much faster in TimescaleDB than in standard Postgres, especially when your dataset grows into millions of rows. Now that we've got some interesting data and queries, let's visualize it. Tiger integrates nicely with Grafana, so you can build dashboards on top of your TimescaleDB instance. I'll assume you have a Grafana account for this demo. If not, you can sign up for one or just watch the demo to see how it's done. Once you've signed up, you may see a screen like this. If not, the first thing we need to do is create a connection. Click on Connections on the left panel, and then click Add New Connection. On this page, click PostgreSQL. On the pop-up that appears, click on PostgreSQL Data Source. Now, on this PostgreSQL screen, click on Add New Data Source. You'll see this screen where you can enter your connection details. The details you need are available on your Tiger dashboard. Enter the host name, database name, and username from this panel onto the Grafana page. It's important to note that the hostname includes the port, so paste the hostname, then enter a colon, and then enter the port number from the connection details panel. Without this, the wrong port is used and the connection will fail. Then enter your password for the database. There are a lot of options here for the connection, but for now we can leave most of them as the default and scroll down. For the TimescaleDB option, turn this on. Click Save and Test at the bottom. After a minute or so, the connection should pass and be saved. Once connected, you can build a simple chart using the data you have imported into your TimescaleDB database. To do this, go to the Dashboard section in Grafana. Then click on New Dashboard. Click on Add Visualizations. You'll see a list of data sources. Select the data source you just added, which in this case is the Grafana PostgreSQL data source. You'll see this screen which allows you to create a visualization based on your data. The default type is time series, shown on the right here, which is okay for us. Let's do this now. First, we'll specify our query. The dataset has many rows for each time, so we want to use our SQL query from earlier which captured the average for each day. Go to the query section at the bottom of the page. You can use the Builder section here to create a simple chart based on columns and functions, but ours is a little more complex. So I'll click on the Code button here, which allows us to use SQL. I'll paste in the SQL query from earlier in the demo, which found the average price for each day for a specific asset. Then click Run Query. This will get the data from the TimescaleDB database and load it into Grafana for visualizing. You'll see the chart here, but you may get a message about the data not being visible. This is because the default time horizon for this graph here is the last few hours. You can click on this Zoom to Data button and the date range will be adjusted to fit the data. We do this and see a nice line graph showing the average price and how it changes over time. This is pretty useful. Now you have a live dashboard showing your time series data updating over time, powered by TimescaleDB. You can also add another panel for minimum or maximum, or even calculate a moving average line using your query. So that's TimescaleDB, an open source time series database built on PostgreSQL. It gives you all the flexibility of SQL, optimized for the kind of data developers deal with every day, whether that's finance, sensors, or logs. Tiger Data has recently announced a truly free tier on their platform where you can access all of this for free. The free tier also gives developers instant access to all of their new AI tooling, including forkable infrastructure for testing, an interface to control agents, integrated search, and persistent memory. All available to test out for free right now with no credit card required. If you want to try it out yourself, use the link in the description to create a free Tiger Data account and start building right now. And if you want to take this tutorial further, check out part 2 of this video on the Tiger Data YouTube channel, where we'll expand on this project and explore more advanced TimescaleDB features. Thanks for watching.